Imagine a completely clean, isolated computer, a fresh installation of macOS, a brand new Google Chrome user profile. The machine is left totally untouched, no one typing, no mouse moving. Privacy researcher Alexander Hanff set up exactly this kind of sterile environment. His goal was to monitor the operating system's internal file system logs to see exactly what applications were doing in the background when nobody was looking. And then the system kernels suddenly spiked. Without a single human command, Google Chrome woke up and autonomously began auditing the computer's hardware specifications, checking to see exactly how much processing power the machine had available. Once Chrome verified the hardware was strong enough, it quietly opened a background server connection. Over the next 14 minutes, it downloaded a massive 4 GB payload onto the computer's local hard drive. There was no pop-up window, no consent banner, and absolutely zero notification. Standard web browsers do not siphon gigabytes of data in the background without asking. This was a deliberate, programmed directive acting entirely on its own accord. The payload is a gigantic binary file. It's titled weights.bin, and Google buried it deep inside a hidden browser directory called OptGuide on-device model. If you discover a mysterious 4 GB blob eating up your hard drive space, your first instinct is to highlight it and hit delete. But Chrome expects you to do that. The browser is programmed to treat manual deletion as a temporary software error. The very next time you open Chrome, it quietly reaches back out to the server and re-downloads the entire 4 GB file. You cannot permanently delete it through normal folders. You have to possess the technical knowledge to navigate into Chrome's hidden developer menu, the Chrome://flag screen, and manually deactivate specific experimental features to stop the loop. This level of resilience is usually associated with malware, but here, a trillion-dollar corporation has actively subverted user autonomy to force an undeletable program onto consumer devices. That weights.bin file is Gemini Nano. It is a highly compressed, lightweight version of Google's large language model. To understand why Google is hiding it on your computer, we have to look at the macroeconomic math. By 2026, tech giants like Alphabet, Microsoft, and Amazon are projected to spend over $700 billion solely on artificial intelligence infrastructure. A massive chunk of that money goes towards inference. Inference is the actual process of an AI answering a prompt or executing a task. Doing that math on a centralized cloud server requires staggering amounts of electricity and highly specialized hardware. Alphabet alone is dedicating roughly $185 billion to fund its AI initiatives. But if every single time a user asks an AI to summarize an article or draft an email, the request has to travel to these massive data centers to be processed, the energy and hardware costs quickly erase the profit margins. Google realized they couldn't afford to process everything centrally. To survive the extreme costs of the AI arms race, they had to completely change where the computation physically happens. The solution is edge computing, pushing heavy computational workloads away from expensive cloud servers directly onto consumer devices. Gemini Nano powers Chrome's new local features. By forcing the model onto your hard drive, Chrome executes the complex math on your processor, bypassing the cloud entirely. Google is solving its $185 billion infrastructure problem by turning billions of private consumer laptops into free distributed processing nodes for its own AI network. This strategy creates an immediate bandwidth tax. If you have an unlimited fiber optic connection, you might never notice a 4 GB background download. But for users relying on metered connections, cellular hotspots, or expensive rural internet, that silent transfer can instantly drain their monthly data caps. This chart shows the immense global scale of the deployment. Pushing a single 4 GB file to just 30% of Chrome's user base requires 4 exabytes of total data transfer. Moving that much data across the internet demands an estimated 240 gigawatt-hours of electrical energy. That generates roughly 60,000 tons of carbon dioxide equivalent, just to distribute the model. Once installed, running the AI model constantly reads and writes to the hard drive while draining the CPU. For lower-end laptops, this severely accelerates the physical wear on solid-state drives and kills battery life, pushing consumer hardware toward the scrap heap years ahead of schedule. Google is effectively levying an unauthorized global tax on public internet bandwidth, local energy grids, and private hardware lifespans to subsidize its distribution costs. This aggressive, silent installation mechanism puts Google in direct conflict with strict international privacy frameworks. Legal experts point out that writing gigabytes of non-essential data to a terminal without prior consent is a flagrant violation of the European Union's GDPR and the e-privacy directive. This isn't an industry necessity. Competitors like Mozilla Firefox integrate AI tools using strict opt-in policies, fully preserving user consent. To reclaim your machine from Chrome, you have to type chrome://flags into your URL bar. Search for optimization-guide-on-device-model, as well as the prompt API, and manually change their status to disabled. The artificial intelligence revolution is no longer contained within massive, corporate-owned data centers. Unless tightly regulated, the computational power needed to run these models will simply be extracted, quietly and forcefully, from the devices of every